Let's get started. Last night, I asked you to complete the clue word list. Get those out, please. Okay, here is my list. Now, as I said the other night, it is nowhere near complete. I mean, almost every semester, someone comes up with a new term that works. But nonetheless, I didn't have it up there. And I have no intention of adding all of them in the world, because then that leaves the opportunity for you guys to have ones that aren't. If you have any questions about the ones that I do have up there, then I would suggest that you ask. Yes.
So I don't understand the one that says coefficient and then multiply.
Coefficient is a number in front of a variable, like 3x. 3 is the coefficient, and 3 is times the variable.
Okay.
Good question. The what?
What is the standard total?
Louder, please.
I use the word total. What does that say? Unite or united?
Oh, unite as in singular, united as in past tense. They are united. They are added together. I don't know if this will let me increase the size while it's up there or not. Understand it, no. Looks wrong way. Yeah, there we go. Is that got all of them?
Oh, that's better.
Yeah. As of last night, I think I already said this, about a third of you approximately had sent me the information PDFs that I requested. And I haven't had the opportunity to check and see if any of the rest of you have sent them yet today. I was working on some stuff for class, most specifically editing a video from last night, and it did go well. But I cannot turn all the lights off when I'm using this, because the room gets black enough that that thing goes crazy trying to adjust to the brightness levels. So I've got to keep the lights on most of the time. Anyway, I'll check. I did reply to some of you that you had to do it over. And because you tried to send it to me as a link in your one drive. And on my computer, I have OneDrive turned off right now, because I'm rebuilding from a crash and I'm not ready for it to start backing up. So you're going to have to send me that as an attached file, not as a linked file. As a PDF. That was part of the requirement. A couple of you sent me JPGs. You got that video that tells you how you can convert them. Yes. That's correct. That's correct. Actually, the deadline on it is tomorrow night. Yes.
I've been trying to do that. I'm trying to follow the video along as well. Since I don't have, I didn't have a parents thing. I've been trying to do
The phone thing.
yeah, it's.
I'm not an Apple person.
Yeah. It's keep putting it in a JPEG.
Well, that's the default method. You do the JPEG, then you convert it.
Yeah.
I see mine today. I don't.
Okay, yes.
I have a question.
Question?
What's HN more later? On number 14 is subtraction.
Subtraction.
Under extracting.
Oh, how much
Oh, okay.
or how many? Okay. I had to stop and think about that one for a moment. It's been a while since I did this particular handout. I'd say probably around 1999 or so. Bunch of you probably weren't hatched yet. Well, let's not go any farther than that. My oldest grandson in 22 is 2099 or 1999 birth. Fact is, he's got a birthday coming up this weekend. Okay, anyone not done with these so we can go on? Yes, okay. Just another moment or two then. Yes.
So, I've never seen president be used as a, in addition to 19 from down, I've never seen that used before. What context would you use it?
Haven't you ever gotten money credited to your bank?
Okay.
Deposited?
I have a bank, I don't have a bank, but. That's something.
Okay. I mean, there are all kinds of words that you just use routinely every day that truly do have a specialized math context. Okay? And that's the point of this, is just to make you aware. I don't expect you to memorize this list. Goodness, no. This is an awareness thing. So next time you go to the bank, you're going to think, well, I'm adding my account.
So would deposit also be covered?
It very well could be, yes. Because usually a deposit you are adding to. Now, in a rare case, a withdrawal could from your checking account or from your paycheck, more likely, could be a positive to your 401. If you want to get kind of weird about it.
What does mean?
That is the formal name for one of the parts of a subtraction problem. Minuend is the amount you take from. Subtrahend is the amount you take away. And difference is the answer or the result of your subtraction. The top three on all of those are the formal names for adding, subtracting, multiplying, and dividing. There's actually, well, not on the first one. There's a first add-in and a second add-in. And sum is the answer. For subtraction, difference, minuend, I had it there somewhere, I guess. And subtrahend, I didn't put those down because you don't really see those much anymore. Multiplication, the front number or the top number is the multiplicand. What you're how many times you're multiplying it by is the multiplier, and product is the answer. Product is a real frequent word that you will see in word problems and instructions for working problems. That always means multiply. Quotient is the answer of a division problem. Remainders, what's left over at the bottom. I left off the two parts on it. The part that's outside the box, or the denominator of a fraction, or the second number if you use the bar and dots division sign, okay? And that's called the divisor. The one on the outside of the division box or the denominator of a fraction is the most common way is the divisor. The number under the box, okay, is simply called the dividend. And I do have it on that list. And I do have divisor also. The quotient is the answer to a division problem. Questions about that? Okay. Well, I'm going to put this away if everyone's done with it. And we'll go to the PowerPoint for the regular list. Just this thing would work better if I turned it off. Okay, here's what we're covering in this particular set of units. Linear equations in one variable. Linear equations. Linear is a math word that means it creates a straight line. What is the root word of linear? L-I-N-E, line. Okay. Yes. Did you say question? Oh, okay. Now, here's the date. I've really talked about this already. And I need to get used to standing closer to the board than up there where I'm more comfortable for the sake of that thing. We talked about equations last time. We talked about the Libra scales. And we talked about the equal sign in the middle being the verb of the words. Okay? And it indicates that there are two quantities are equal. 2 + 3 = 5. Yeah, they're equal. They're just in different form. Oh my goodness. Did you hear that statement in the weird number? In different form. Just a different shape. Okay? Solution. If it asks you to find the solution, they're asking you to get x equals some number. Or numbers, depending on the problem. Okay? Now that's different than expressions, which are a half equation. That's just the first half of it. Those they would use the word simplify instead of solution or solve. Okay, the solution set of an equation is the set of all answers that make it true. Okay, that make it true. Now, if it's a less than or equal problem, you can have infinitely many solutions, and we'll discuss ways to write that. If it's an identity problem, then any number will work. If it's a contradiction, there is no answer that will work. And then there are problems which have one and only one unique solution. So those are the different possibilities. And we'll discuss all of those in more detail. Okay. Here are some rules or properties for equation solving. That's what these are. A, B, and C just stands for some number. A could be 3, B could be 5, C could be 11. It doesn't matter. Okay. What this tells you, though, is that A is not 0. So it's something different than 0. One of the other two could be 0, but we don't know right now. Now, a linear equation in one variable is an equation that can be written in this format right here. AX plus B = C. AX plus B = C. Now, later on, not very much later on, you'll have it in the form Y = MX plus B, which is the standard format or linear equations. That's the one of the two. It's called the slope-intercept form of an equation. Now, linear equation of one variable is called a first-degree equation. That's because x is to the first power. Okay, that's why they call it a first-degree equation. If that were an x squared, it wouldn't create a line. It would create a golden arches, okay, or a jump rope. If that were a square, if it were a square. Now, then it would be called a second-degree equation or a quadratic. So everything has a name and a place in math. And language is huge in math. And that's why I'm going to make such a big deal of it this semester. Because if you can't talk the language, you can't get a meal in that French restaurant. Okay, it's kind of a similar sort of a thing. Okay, linear equations in one variable. Okay, here we're going to solve them. We're going to clear fractions and decimals, and we're going to do conditional, contradictions, and identities. And I mentioned those just a couple of minutes ago, those three styles. By the way, if you notice, a lot of times I do a little bit of looping. I'll hit you with something light, and then I'll get you with it later a little bit. Okay, let those represent our numbers again. Here are the properties I told you were coming. These are things you can do. Let's go to our scales. Right now, they're balanced. All this is saying is if I add this, here's this balance scale right here. All this is saying is that if I add the same thing to both sides of that balance scales, it will stay in equilibrium. Okay, that's all that that's saying. Now, you can add the same thing to both sides. You can subtract the same thing from both sides. You can multiply the same thing on both sides. And you can divide the same thing on both sides. And that rule will hold true. Question or acknowledgement? Okay. Subtraction property. You can subtract the same thing. Again, I'm repeating myself. Okay, this time they're letting C not be 0. Multiplication product. Here. If A equals B, scales are in balance. Okay. If I increase the weight 3 times over here, as long as I increase the weight 3 times over here, I'm still in balance. Now, why would they outlaw or discredit the C?
So no matter what you multiply by 0, it's always 0.
Exactly. Very good. 0 reminds me of the old 60s song, Wipeout. Any of you ever heard it with a big drum solo? Pretty cool song, actually, even today. Now, that's what 0 does to something. It wipes it out. So this would be meaningless if you multiply both sides by 0. Okay, the division property of equality. Again, this time, C cannot be 0 because you cannot have a 0 in the denominator, ever. If you do, I mean, it's possible that you could get one there, but if you do, then that problem is undefined. It is unworkable because you cannot divide by 0. Let me illustrate why. Let's go back to 3rd grade math. You work this problem, you get a 5/15, right? 0 remainder. How do you check this problem? You take 3 times 5 equals 15. The divisor times the quotient equals the dividend. There's that language again. Okay? Now, what about this?
It can be anything.
Could it be 3?
It could be.
Well, 0 times 3 equals 0. Can it be 5? 0 times 5 equals 0. There's no way it can check. Okay? So, and even 0 times 0. So 0 is not even a valid answer. Okay? So that's why we call division by 0, or a 0 in the denominator, is undefined. It's because you can't do it. A lot of times you're going to see that I'm going to take an extra moment or two and try to tell you how come things are the way that they are. Okay, let's solve this equation. This could represent pennies. Okay, I didn't want to draw 40 little bitty circles. Now, how can I check this problem? I've got a certain number of pennies in the box. I don't know how many. But I know that the balance of these two has to equal that. So if I take these 12 that I can see away from here, and to keep balance, I take that 12 away from here, then that tells me the number in the box is equal to 28. Okay? That's all equation solving is. It's keeping stuff in balance. How do we solve it? By adding the opposite. We are undoing that problem. That x, which you want to isolate it by itself, has an add-on that you want to get rid of. How do you do it? Subtract that add-on from both sides. Always do the opposite to undo equations. What if that had been a minus in front of that 12? Then we would have added 12 to both sides. Okay? What if that had been the 3 times the box? Then we divide both sides by 3. And that's how this system works. Okay, well, they're showing it now. I don't show it that way. Here's how I would show this problem. 12 plus x equals 40. I would show minus 12 vertically rather than horizontally. Because it's kind of a pain figuring out how much you need to leave for space for stuff that way. And here it's not. Okay, so these two wipe out, leaving x. And these two give us that same 28, don't they? If you need to, and if it helps you, you can draw a balance scale on your problem to help your thinking. That you got to keep it in balance. You got to take away the same amount from both sides of the scale or whatever. Okay. And there's the 28. Here they check it. Here's how do you check them? Well, we take this 28 that we got here, and then we substitute it in where the x used to be. Now, And notice they put a parentheses around that 28. When you are substituting a number for a variable, always enclose it in a parentheses initially, especially if it's a negative number. Especially if it's a negative number. Okay? Well, anyway, 12 plus 28 then is 40, so we get 40 equals 40. My equation is in balance, and the world is good. Okay? And that's the way the system works. And there's the solution set, the set of numbers that have the 28 solves. Okay, here's another one, got some negatives in it. What are we going to do on this one? We're going to add to both sides. Do that on a scratch, please. Work this problem, x minus 5 equals negative 11 on scratch paper, please. Get in the habit of showing the steps. That's why I'm saying on paper rather than just in your head, as my hillbilly cousin would say, in your head. Now, I can get away with doing that because the first 9 years of my life, I grew up in southern Arkansas, little town called Paris. Somebody asked me where I was born. Oh, I was born in Paris, Arkansas. And then I went to the rest of it through high school and college in Oklahoma. Went to the Army and came back to Kansas. Okay. What are we going to do on this? We're going to add 5 to both sides, right? So plus 5, that's going to give us negative 6 for the answer, right? Okay. Does anyone need me to put that one on the board? No. Okay. Uh-oh, this one you might. Oh, you guys just love fractions so much, right? Your favorite math thing. You don't have to work this one yet. Well, you may want to copy it down. I'm going to work it, but believe it or not, when it comes to algebra, fractions are your friend. They are vastly easier than decimals when you don't have a computer or a laptop. And you don't in this course. And if you're using one at home while you're doing your homework, you are hurting yourself on the tests. You need to get where you think these operations and numbers and be able to represent them on paper. Here's my soapbox. Okay, well, this one is a multiplication, right? We've got a negative 3/5 times that p. And over here, we got another fraction. Now, this one's multiplication, so it's pretty easy. Subtraction of fractions is one of the hardest skills because you got to play the common denominator game. Okay? But let's go over how you would work this one. Well, actually, I think I've got the slide. First thing I would do, what is the reciprocal? Whoops, hit the wrong button. What is the reciprocal of negative 3/5? It's negative 5/3. Okay, just flip it over, right? That's why I call it dolphin math. Flipper. That's a groaner for sure. And what you do on this side, you got to do the same thing on the other side. So now, there are 2 ways you can show this. You can cancel those 5s and cancel these 3s and cancel those negatives and end up with a positive 1p over there. Or you can say 5 times 3 is 15, 3 times 5 is 15, negative times negative is positive, and still get 1p. Over here, you can cancel the 5 and the 15. 5 goes into itself once. Let me show you how I would show that work. Okay, this one we got down to 1p already. Oh, I skipped something. How about this? Oh, I totally messed it up. There, now is it right? Yeah, now it's right.
It should be 4, 14.
Thank you. You guys gotta keep me straight on this stuff. All right, now, we took care of this and you get 1p. Over here, the way I would show this is I would do 5 goes into 5 one time, 5 goes into 15 3 times. So if you multiply that 1 times 4 and the 3 times 3, and there should have been a minus right here, I believe. No, there was not. So there should be one here. And that's the answer. Now, what have we done here? We have pre-reduced. You could have done -5/3 times 4/15, and you could have had 20, numerator times numerator, over 45 with the negative out front. 5 goes into both of these. 5 goes in there 4 times, 5 goes in there 15 times, and end up with -4/15 or 4 9s this way. This way of doing it up here is just free canceling. And I think, well, it isn't much different either way. But what if you had 1,000 down here, or 2,000, or 2,500? Then you would have big numbers to deal with down here. So it's just usually easier to pre-reduce them. Okay. Your grade school teachers told you that was canceling. It is not. It is actually literally factoring. Canceling is an add subtract word. Now, will you ever hear me call it canceling? Yeah, because I've been doing it since I was 8 years old. But it's actually an incorrect term. When you cancel something, you get 0 for the answer, like we did earlier. Okay, well, they're showing it the same way I did and getting that. And then the solution set. Okay, here's another problem. This time we got this here. What is the opposite of division? Multiplication. So we are going to multiply both sides by the divisor of 2.2. We're going to multiply both sides by 2.2. And here it is, 2.2 times 4, 2.2 times that whole thing. Guess what? These two will cancel out. And those two multiply to 8.8. So that's our answer. Okay. Any questions about what is division? What are we doing in every case? We are doing the opposite. It showed division, we multiply. Before it showed multiplication, we divided, etc. Okay. Uh-oh, this is something new. We got a negative variable. First time I've shown you that. Well, we still got this add-on. No, we don't have an add-on at all, do we? Now, what is hidden in front of that x? A 1. So how can we get rid of that negative sign? Or divide. How would I show this? I would show this as negative x over negative 1 equals, what is it, 6 over negative 1, or in other words, x equals negative 6. Now, later on, if you've got this, you just know that you're going to change both sides and be happy. Okay? But I would do it this way with division. It's easier not to make a mistake, or for me. Now, you notice that I started to draw a flat fraction bar and I changed it to a slanting one. I have another soapbox to stand on. What is that number?
147.
Okay. You're saying this or that? Well, the only time I want you to use the slanting fraction bar is if you're showing dividing both sides. Okay? So I should have done that over here too. Okay. If you're just writing a fraction out, notice on all of these, I showed it as flat bars. Sometimes you're going to be bringing steps down. And if you start putting them off to the side, you can lose them. They'll hide on you. Okay, they're rascals. They're kind of like some of those minions in that new story. They can be mischievous. But if you use flat fraction bars, you're much less likely to make just an error on that basis. Oh, here's some more. Now, I'm not going to have you do those. We're going to kind of blow through these, but just talk about them very quickly. Okay? What's our strategy? And this is a habit I want you to get into. I want you thinking of a strategy. How am I going to approach this problem? Okay? If you make arithmetic errors, that's only maybe a 1 point. You could make a mistake right at the first step of a 5-step problem. And if you carried that same error through the whole rest of the problem, you'd still get 3 out of 4 points. Okay. The important thing is, do you use the correct strategy to solve a problem? No matter how complicated, or especially if it's complicated. So anyway, on this, what is our strategy going to be? It's going to be to multiply both sides by -5/6. On this one, what is our strategy going to be? It's going to be to multiply both sides by 16. And this one, what are we going to do? Divide by what? -1. Okay. Okay, here are the order of steps. Don't write these down. I got something better for you in a minute. Handout number 6. Okay. You're going to clear parentheses. Sometimes you're going to have to remove double negatives on integers. Clearing fractions or decimal if any are there. We'll talk about that more later. Multiplying, dividing, adding, subtracting both sides. Okay, combining like terms. We talked about that last night. I sound like I'm getting hoarse. It's for teachers, that's a professional hazard. Probably by this time next week, I'll be good, of course. Now I just have to teach class totally silent. I've done that. It's not fun. Okay, here, well, it's kind of a challenge. Okay, you use the properties of adding, subtracting, and all of that, collecting them on one side. That's just some of that stuff we've already gone over, right? And then check at the end. Okay, solve and check. What's our first step going to do? Now, time out. Any of you remember my dear old Aunt Sally?
Yeah.
From grade school. What was my dear old Aunt Sally about?
No.
On an equation, or not an equation, but a string of numbers anyway, adds and subtracts and multiplies and parentheses and stuff. The first thing you did is you cleared any exponents if you had them. Second thing you did is you cleared any parentheses if you had them. Then we got down to My Dear Aunt Sally, which just simply said the M standing for multiplication, the D standing for division, that you do those two things first in order to correctly work the problem. Okay, and it didn't matter whether you did multiplications or divisions, it's how the order they came left to right in the problem. Because you always read math problems like you do a book left to right. Okay, then you had additions and subtractions, the order is left to right. And then supposedly, you know, you add all the stuff and finish it up and you get the correct answer, we hope. But guess what? After going through all that My Dear Aunt Sally stuff, to solve equations, you do the opposite. You get rid of the add-ons and subtract-ons before you get on to get rid of the multipliers or the dividers. Okay? You always get rid of, your goal is to get x by itself. So you start from the outside and work in, kind of. So you get rid of any add-ons first. Then you do multiplication or division to get a singular x. Okay? So our first step on this, we're going to subtract 1 from both sides. And again, I put them underneath. Then when we simplify that, the ones cancel out. You got 3x on the left, you got -8 on the right. Now we're ready to divide by 3. See, this is just the opposite of order of operations. Because why? I used the word before. Did anyone remember or stick in your head the word I used for how our strategy to solve equations? You undo them. Remember saying that before? You undo them. It's the opposite of order of operations. Then we divide both sides by 3, and we get -8/3. Now, in grade school, particularly 7th or 8th grade, your math teacher probably would have told you, oh, you got to take that 3 and divide it into 8 and get a mixed number for your answer. Not in algebra. Simplified or reduced improper is the way we want it left. But if you had 16/6, you'd be expected to reduce that. Okay? So reduced improper is proper. Now they're just checking it. They're taking this -8/3 and replacing it where the 3 is, and there's the x you can't see, and here's the 1 and the 7. Okay, in this case, we take the 3 times the -8/3, and we get -8 plus 1 is -7. And that matches, so we're true. Now, get out this is handout 6. You're gonna write on it. Okay, what I'm giving you here, I've got to do some erasure, is this equation chain is a general sequence for solving any kind of linear equation. This particular one is going to have multiple variables, which is something I haven't shown you yet. Okay, but the method that this will describe will work with any level of linear equations. Okay, some may just be more simple than this. Story behind this, I sat there in service with a group that came in that thought they had the answer to execution. They, about the 3rd day, when I was just, they gave us an assignment to come up with some sort of demonstration how to do some math problems. This is what I created. They said, oh, can we use that? I said, only if you want to pay me. So I copyrighted it myself. Now, yeah, this says this was just because I put it on their paper. It's my copyright. Okay, Now, here's the equation up here. 3 times quantity x minus -4, and mine's going to look slightly different than theirs, equals 12 plus 3x minus 2x. Okay? Notice the difference here. They've got that extra parentheses in there because the typesetter won't let you elevate the negative. Okay? That just means you are subtracting a negative number. Now, if you have things like that, then the first step that you're going to want to do in the chain is convert any minuses to pluses. Well, it takes 2 changes. You change this to a plus, and in this case, since they're the same, you change that to a plus. Minus a negative, if you take away a negative, you're adding. It's a double negative, just like in English. Okay? So we got 3 times x plus 4 minus 2 equals this other stuff. Okay, now, my second step is something called the distributive property. Okay, I played a song last night. What was the song? Come on, guys, girls. John Denver, Rocky Mountain High. Why Rocky Mountain High? Because we are going to distribute that 3 to every number in the parentheses. There's my mountain tops. So I get 3x plus 12, and that's where I made my mistake last night, wasn't it? I goofed and forgot to carry across the second one, which is the most common mistake that students and instructors sometimes make. Okay? Now then, what is our next step? And that's an only if step. Okay? Only if you need to. And these first 3 I filled out for you anyway. Okay, now you simplify or combine like terms. Do I have any like terms here that I can combine?
12 minus 2.
Yes, the 12 and the 2. So I've got 3x plus 10 equals over here. I can combine these two, 12 plus 1x. Okay? Now then, I'm at the point where I need to separate the x's. Okay? That sounds like divorce court. Sorry, that's not necessarily a funny joke. All right, so I'm going to take the variables on this side. That's just an arbitrary choice. So I want to get this that way. How am I going to do it? I'm going to add its opposite to both sides. Like so. And that is what I call the first critical step. That, showing this, is a partial credit point show. Okay? This is the kind of stuff I look for when I'm trying to award partial credit when the final answer is right. So we now are going to simplify again. Well, in this case, 3x minus x is 2x. And I still got this hang on 10. And I now have the 12 because these two kill each other off. They wipe out. Okay? Now I'm at the point where I undo the equation. Everything I've been doing up to this point is just simplifying. Okay? So, there I collected, now I'm going to collect the numbers on one side. So I'm going to take this over there, minus 10, minus 10. And the resulting simplification then will be 2x equals 10, or 2 rather. Okay? What do you suppose I do next? I get rid of this coefficient of 2. This coefficient language of 2. How do I do it? I divide by 2 both sides. And then that results, after I simplify it, of 1x equals 1. I box it, but I'm not done technically. Substitute the 1 everywhere an x is, do order of operations on it, see if you get the same number on both sides. Okay. Here is actually your solution, but if you put a 1 here, and you put a 1 there and a 1 there, and then you do order of operations to check it, you should come out with the same answer on both, same number on both sides. Whatever that number is, it doesn't have to be 1. It just has to be the same. Questions about the steps used to solve equations? That pretty much covers every linear equation. Okay. Now, are you always going to check every single problem? Probably not. And you very well may not on the final, because you need to get every problem worked first. Then go back and start checking. Is your strategy there? Yes.
So for partial credit, when it comes to like quizzes and tests and whatnot, if we go through all the way up to like the simplified fraction of real numbers before we substitute, then we can still get partial credit at that point.
Yeah.
Okay, I just wanted to make sure.
You'll get partial credit based on how correct it is, how major or minor your errors are, okay, or how frequent they are. 2 mistakes drops you to a 2. Okay, 1 mistake, even though it was made on the first step, like if I made a mistake way up here, but carried everything else down correctly from that, would still only cost you 1 point. Does that answer your question? Yes. Okay. All right. Here's another one. We're going to solve this one just exactly like we did the last one. What's our first step in our strategy? Remove the parentheses, or in other words, use the distributive power, or distributive property rather. So we're going to take this 5 times z and get 5z, and this 5 times -2 and get -10. I really encourage you to draw your mountaintops, but you don't have to. It's just a little error prevention. One of the courses I took in my undergraduate, no, my graduate work in mathematics was with Dr. Camps at KU. I did my graduate work at KU and WSU. And at any rate, this class was called Error Patterns in Mathematical Computation. It's probably the most worthwhile course I've ever taken. Okay, so we did the distributive property. Now we're going to simplify a little bit. Okay. Well, no, actually what they went to next is they took the -5z off of both sides because they're wanting to put them on the left. You could, it might give you a negative number, negative x value that you have to convert it to. But yeah, you could do it the other way. And sometimes it's to your advantage to do it the other way. With just the right numbers. Okay, so now we've simplified. Now we're going to get rid of that 2 by adding -2 to both sides. And now we simplify. Doesn't that sound like a repeatable pattern? And now we're going to divide both sides. And now we simplify, and that's our solution. So see the value of this chain I just gave you? Okay. And you're not going to find that chain in any textbooks. Like I said, I have the sole copyright on that. I gave it to a number of junior high and high school teachers at both Kansas State Association meeting as well as the National Middle School Conference in New Orleans and Portland and Louisville that I also participated in. Okay, there's the answer on it. I don't know why, and the chat. You can see they just did order of operations beginning here. There again, they did the substitution using the parentheses. In that case, they didn't do it in this one. But here's another one. You feel like we need to go over it, or do you think we can keep going? It's going to be identical to the previous two. What? Okay. Solve this one. This one's a little nastier still. It's got even more numbers. What's our first step in our strategy going to be? Get rid of that minus in the middle. Ah! Those things are horrid. They will screw you up. Now, they may not show it this way. They may not show it this way, but this is what I recommend you do on cases like that. Now remember, there is a hidden one behind that minus. That helps your thinking a little bit. Okay? So if I had 7 minus x plus 1, like so, first I'd uncover that. And now I'm going to distribute this -1 to both of those. So I will have 7 plus -x minus 1. Okay. Or 7 plus -x is just simply 7 minus x. Okay. Now the other side is pretty straightforward. Okay, here we go. They've gone to this step that I have. This is how you think this, however you get to that step. Okay. Okay, so now what did we do? We combined like terms. We added the 12 and the 2. We added the 7 and the -1. At this point, we decided to take this x over there. So we added its opposite here and here. Added -x to both sides. Remember, I would show it underneath instead of out to the side. Resulting, after simplification, in this, a standard linear equation. Mx plus b equals 6. Okay, well, anyway, we're going to get rid of that 14 now. So we're going to add -14 to both sides and simplify. And now we're going to divide both sides by -2. -2 and -2 cancel. -2 and -8 give you +4. It just repeated that same bottom step from before up here.
Well, I was one
See?
step ahead.
The bottom, oh, you were up here still?
Yeah.
Okay, well, this bottom step is repeated, is why I went through it so quickly. Yes?
In the beginning, did you not just distribute -1?
For this side, that's what I did do. Yeah, that's what I did do over here, resulting ultimately in this. That's okay. As long as I'm happy that you caught your mistake. That's important. when you get where you can recognize your mistakes, then you are truly successful. Okay? That's the test of true success in algebra. Okay, I go on now.
Yeah.
Okay, here's that last step on the other one, divide both sides by -2, giving you +4. And the check. Well, they just tell you that, and they didn't check this one. Oh, even another nasty one. Well, to do that one, guess what? That one's not gonna be shown up here. You gotta do it. While you're doing it, I'll work over here, okay? But try not to look up until you have to. Okay, first thing I gotta do is get rid of some parentheses. So I'm gonna take this here and here, and I'm gonna take this combined -6 here and here, resulting in, shut up so you guys can look. And I like you always box your final answer. Now, a couple of you looking puzzled, but I made a mistake somewhere.
Is it 3t?
Where?
3t plus
2t plus t is gonna be 3t plus 14.
Which line?
6.
Which line?
Where you're combining. where you're
Which
bringing variables.
line?
Fourth line.
Fourth line, 1, 2, 3, 4, here.
Mhm.
Yeah, that should be 3.
Well, yeah, I'm adding, aren't I?
Yes.
Well, I'm lucky that the mistake wasn't up here high somewhere. So I'm not done yet. So I've got 3t equals -8. I divide by 3. I divide by 3. And I get t equals -8/3. Now does it look better?
Yes.
All right, good. Thank you. All right. See how easy it is to make little blunders? And you can just blow right through them. Or at least I can, obviously. Okay. Questions on this one? Any more? Or corrections? Okay, solve this one. This one has something new. It's got brackets. Oh, God. Nope. Nope. Brackets are just big parentheses. Okay, in your computer, you just have to use double parentheses. That's called nested parentheses. They're just bigger parentheses. So what that means is I'm going to take this -4 eventually times all of this, but you want to always work from the inside out when parentheses are involved. Always from the inside out. So that means we're going to deal with this parentheses before we deal with the brackets. Okay, so let's simplify this. Now, they did it a little bit differently, but -3 times y is -3y. -3 times -5 is +15. They did the distributive property here and there. And consequently, that parentheses is gone and you got this string. In this step, they also took the 2 times 6 and the 2 times -5y over here. Now we have to do with these super parentheses. We take the -4 times each of these 3 terms. Okay, so -4 times y. Ooh, that's kind of messed up. They're just showing that you're about to do that. Here's the result. -4 times y. They did 2 steps. I'm going to write on the board what should have been up there that you can see. Okay, we got -4 brackets y minus 3y plus 15 brackets equals 12 minus 10y. Okay, you do this, you do this, you do this, and you get -4y minus 12y minus 60 equals 12 minus 10y. Okay? Except this one should be a plus. Okay? Now, -4y and 12y makes 8y. So you see they actually skipped a step. I don't recommend you skip that step. Okay, so you got the 8y minus 60 equals 12 minus 10y. Now, let's combine like terms, add 10y to both sides. I'm adding, so I don't make the same mistake I made last time, which in this case gives me 18y minus 60 equals 12. I get rid of the 60, I add 60, I add 60. So I get 18y equals 72. Then I've got one more step. 18y equals 72. So I divide both sides by 18. And 18 conveniently goes into both sides. Anyone know how many times? 24 goes 3 times, so 18 is going to go 4. That's mental math. Now, what if you didn't know that? 9 goes into all 4 of those numbers. 2, 2, 8, 3, right? The 2's cancel out. So you get 1y. The 3 and the 8 won't do anything, so 8/3. See what I was talking about, always trying to use level fraction bars, because sometimes you bring them up and down when you're doing your canceling or pre-reducing. That's all that is pre-reducing. I picked a common number that would go into all of them.
Shouldn't that be 2?
What did I do? Did I
The
screw up?
18 should be a
9 goes
2.
into 18 twice. Yeah. So I'm not even done yet. And this would be 4. Well, I'm glad you guys are paying attention. I really am. No, I'm just testing you. Okay, questions about any of this? Don't skip steps. It would be easy to go from that and not get this. Okay? So I highly suggest that you always put in those steps. Well, ultimately, they got the same answer we did the second time. Little self put down there. Well, here's another one. Do I need to do this one or can we go on? Go on? Okay, we're going to get started on something very quickly. Anyone care if I go 5 minutes over to? If it is a problem, go. But if you will indulge me, I would appreciate it. Okay. Here are the rules. What are these terms up here? What is SS? Is that some Nazi thing? No, no. SS stands for same signs. Okay, meaning both numbers are both positive or both numbers are both negative. Is what S means. DS means they have different signs. One of them is a positive, one of them is a negative. Okay. Now, the rule for addition, first, if they are the same sign, I'm limited by having so little board space. I'm used to spreading out this full length here. Okay. Four possibilities, right? Okay. These two have the same sign. So what does the rule say if they have the same sign? It says add the numbers, 8, and give whatever sign they're using. Okay. These two have the same sign. Add the numbers and give them whatever sign they got. These two have different signs. What does it say? Subtract the littlest from the biggest number and use the sign of the biggest. Boy, is that improper grammar. Littlest, biggest. It actually, I could use the phrase the absolute value, the least absolute value and the greatest absolute value. But it's just easier to say littlest and biggest. Okay, but that's what that really refers to. So we take the 3 and the 5, we're going to subtract them. We're going to take the little one away from the big one. And in this case, we're going to get 2. And we're going to use the sign of the biggest one, -2. Doesn't that make sense? These two makes -2. Because this one's 2 more than that. Okay. Now, what about this one? Again, we got different signs, so we're going to subtract the littlest from the biggest to get 2 again. But this time, the sign of the biggest is positive. Okay? And that's all that the addition rules are. Very simple. Okay? What about the subtraction rules? I may just leave those problems up there and make one change. Change these all to minuses. Now, here, what do the rules say? Convert the problem to an addition problem. Very simple. Takes 2 marks. Change this to an addition problem and reverse the sign behind. We are changing minus a positive plus a negative. Since you are changing both of those, it is still an equality. Okay. Now, here, change both signs. Here, change both signs. Here, change both signs. So that's the first step on subtraction. Yes. No, I am only changing the number behind the minus. The one that's behind the minus. Okay, here's a way to make you remember it that's a little bit silly. Change the minus to plus and reverse the signy behind. No, that's dumb. Okay, so we have done that. Now, after you've changed these to plus signs, you use the addition rules. Okay, we're going to add these two numbers. Whoops, different signs. So we subtract the littlest from the biggest to get 2, and the sign of the biggest is negative. Here, I've got different signs. So I subtract them, I get 2, and the sign of the biggest is positive. Here, I've got same signs, so I just add them, and the sign. Here, I've got same signs, so I add them, and I use the sign. Okay, pretty simple, right? But you've got that critical step in there of changing both, converting the minus is what I really like to call it. Okay, and how do you do that? By changing both the sign, the negative sign or minus sign, and the negative or positive that follows. Okay, now, I would like to have you, wonder how long that's been up. Student, that just went out on video. A student signed in and it put their name on the screen covering up what was on board. I don't know, I didn't notice how long that's been that way. Oh, wow. The audio will still be there, but oh, well. Now, I kind of lost my thought. Oh, handout 39. Our addition and subtraction problems, right? Unless I accidentally stuck them backwards in the printer.
Yeah, 40.
Okay, the addition problems are what I want. I would like you to do these before Thursday. No, both sides. Both sides. And by the way, this is a graded assignment. Meaning in the grade book kind of assignment. It'll be in 2 parts. We'll also do the back page eventually, but I want to go over instruction for it. I don't have time tonight.
So was it 39 and 40?
No, for tonight, just do the addition subtraction side. Okay, now, on the subtraction side, I want you to show me this conversion. Okay, most of these are simple numbers. Really, this should not take you more than 15 to 20 minutes, absolutely. Okay, there are some fraction problems at the bottom. Be prepared to at least make an attempt on them. And if you have a question on them, then we can go over them first thing tomorrow or Thursday. When I say tomorrow, that means the next class, whatever day it is. Okay, I may say tomorrow on Thursday. but no way I'm being here Friday. Okay, so peace be with you.
So we're not gonna go by that?
What? We've already gone over 5 minutes. Yeah, oh, yeah, you're right. I need to move the downtime. Hey, guys, I got you out on time.
Actually, I need to talk to you.
Just have a seat, wait a couple of minutes.